So we're going to go over parametric representation. So we're just going to want to go over this kind of rule of systems of equations that we're going to jump into and start to understand the more that we work on this. So if you have two variables, the system of equations is properly constrained if you have two equations. So two variables, you need two equations. So let's jump into a problem to kind of make us understand that. So let's just call it problem 1. So if I had two equations, a system of equations, 2x minus y equal to 3, and negative x minus y equals to 6, what would my solution be? You could do this a couple ways. I'm just going to do this graphically to start. We're going to do a lot more math soon enough. So this equation, equation 1 here. 2x minus y equals 3. Well, that's going to turn into negative y equals negative 2x plus 3. I subtracted 2x on both sides. Now I'm going to multiply by negative 1. Y equals 2x minus 3. It's equation 1. Then for equation 2, let's do similar. 2. Negative x minus y equals 6. Plus x, I'm going to get negative y equals x plus 6. Then it turns into y equals negative x minus 6. This is equation 2. I just need to graph them. We know how to do that from Algebra 1. I'm going to paste that into here, if it lets me. Already graphed this beforehand to be prepared. We'll come back in a second. Boom. Okay. So I got handy dandy Desmos over here. So in this equation, once we graph these two lines, 2x minus y equals 3 and negative x minus y equals 6, you'd find that the answer is where they intersect. Your system of equations where they intersect, be at that point. So for this problem, when x equals negative 1, y equals negative 5, that's our solution, and we know that negative 1, negative 5 would be our solution in the xy coordinate plane. You have two variables, two equations, you have a point as your solution if they intersect. So now we get into problem 2. What happens when we have only one equation and two variables? We need to represent using parameters to represent parametrically. x1 minus 3x2 equals to 3. Well, I'm just going to solve for one variable. So, step 1, solve for one variable. So, that means x1, adding 3x2 to both sides, I get x1 equals 3 plus 3x2. Okay, that's great. So, x2 can be any value. Why? Because x1 just depends on x2, and x2 could be whatever we have in this scenario. So step 2, I need to define a parameter. Define parameter t to show it's a free variable. So I'm just going to say that x2, standard is usually t, but I mean I could say x2 is equal to to any variable that makes sense, really. So I like saying x2 equals to t. So I'm going to substitute that in. x1 now equals to 3 plus 3t. Okay. So then we just want to show for a scenario. So if t is equal to 1, I get x1 equals to 3 plus 3 times t. And t is 1, which is equal to 6. So if t is equal to 1, then we know x2 is equal to 1, and I know x1 is equal to 6, and that would be our solution. Just to show you one more example, say what if t is equal to 3? Well, I know x2 would be equal to 3 because x2 equals 3. Then x1 would equal 3 plus 3 times 3, which is 12. We're going to end that right there.